Now the next change that takes place during mercerization is there is improvement in luster of the cellulosic textiles. What are the reasons that the luster gets increased? First reason is the cross-sectional shape changes from kidney shape to round shape. That is, structurally you can show it. This is the kidney shape. And after mercerization, it can get converted into round shape. So there is significant change in the cross section of the fiber. The second change is deconvolution. Deconvolution of the fiber structure. That is, convolutions. These are the convolutions. And after mercerization, cross section somewhat becomes rounder in shape. So convolutions gets removed. And the third change, that takes place is there is more reflection of light and less internal scattering. More reflection of light. Due to more reflection of light, the luster is increased. Now, coming to the next change that takes place in properties of cellulose is gain in strength. So, the first reason for gain in strength is increased orientation of chain molecule, and second change is removal of weak spot in the convolution. This can be shown as these are the weak spot, and during mercerization these weak spots gets removed. Now coming to the next changes. Next change is increase in absorption. This is due to there is increase in hydroxyl groups by 25% during mercerization. It's the main reason why the absorption takes place. Coming to the next changes, there is increased diaptic. Increased diaptic is due to reduction in lumen size of the fiber. And second point is less internal scattering. Coming to the next changes, there is increase in physical compactness. The sole reason for this is increase in orientation. Fiber chain melting. Another changes that takes place is removal of immature cotton. And the reason for this is in swelling and changing cross section of fiber. So these are the major changes that takes place in the properties of cellulose during mercerization. Now there are some factors. There are some factors that actually affect the process of mercerization. Now let's discuss about factors affecting mercerization. The first factor is concentration of sodium hydroxide, which is expressed in total. Now, what happens here is above 56° total sodium hydroxide concentration, there is significant increase in luster. But below 48° total sodium hydroxide concentration, there is decrease in luster of the fiber. The second factor is temperature. The best result is obtained at the optimum luster is obtained at a temperature of 18 to 20° centigrade. Now, above this temperature, if the temperature is increased, the luster is reduced. Also, if the temperature is decreased, there is also loss in luster. Coming to the next factor, that is tension. So the optimum tension for mercerization process is, optimum tension is length and width. That is original length and width. be maintained. Now, if the tension is increased, then the luster is also increased. But if the tension gets reduced, or if there is decrease in tension, then the luster is reduced. Now, coming to the next factor, that is time. So, the optimum time for mercerization is 30 to 60 seconds. Now, if there is decrease in this time, then there is increase in luster, and when the time period is increased, there is no significant increase in luster. So, these are the factors that actually affect the process of mercerization. Now moving on to the next topic, that is condition for mercerization. What are the conditions of mercerization? First is impregnation of cellulosic textile at 56 degree total concentration of sodium hydroxide. Second is tension, which is maintained at original length and width of fabric. Then the dwell period, time is around 55 seconds, and the final step is washing off to remove any residual alkali. Now, these are the conditions for mercerization process. Now, after mercerization, how we will know to what extent actually mercerization has been taken place? To determine that, we have a step which is called determination of degree of mercerization. Now, the basic concept involved in determining the degree of mercerization is mercerized cotton absorb more barium hydroxide solution, then the unmercerized one. Now let's come to the procedure. First, 2 gram sample each of mercerized and unmercerized cotton is dipped in a conical flask having N/4 barium hydroxide solution at room temperature. The next step, 10 ml each of this solution is taken out and titrated against N/10 hydrochloric acid. Here the indicator that is used is phenolphthalein indicator. The next step, a blind titration. Is also carried out between barium hydroxide and that is N/4 barium hydroxide and N/10 hydrochloric acid. Now to determine this, or to determine the degree of mercerization, there is one formula used which is called as barium activity number. Or in short, you can write it as BAN, which equal to capital B minus capital M divided by capital B minus capital C multiplied by 100, where capital B equal to volume of this cell in ml required for blind titration. Capital M equal to volume of HCl in ml required for mercerized cotton, and capital C equal to volume of HCl in ml required for unmercerized cotton. So this is the formula, and for a fully mercerized cotton the barium activity number is around 150, and for a semi-mercerized or partially mercerized cotton, the barium activity number falls between 120 to 1. For a fully mercerized cotton, barium activity number is equal to 150, and for a semi-mercerized or partially mercerized cotton, the barium activity number falls between 120 to 130. So, with that, we conclude the process of mercerization. Thank you so much. Hello everyone, I am Birendra, lecturer in textile engineering. Today we are going to discuss about one of the most important chemical finishing process, that is mercerization. Before going into the topic, let's understand what actually mercerization process is. Mercerization process is treatment of cellulosic textiles, that is yarn or fabric, with concentrated solution of sodium hydroxide with or without tension. The most commonly used fibers that are used for mercerization are cotton and flax fiber. Before starting the topic, let's move on to the introduction part of it. So initially in 1844, John Mercer, one of the English chemists, observed the effect of mercerization by treating the cotton fiber with the concentrated solution of sodium hydroxide. In 1850, he patented this process in his name, and the process was named as mercerization. Later on in 1890, Horace Lowe, one of the finest English chemists, found that controlled shrinkage leads to improved fabric luster, and he also patented this process later on. Now, let's define the process of mercerization. Mercerization is defined as the treatment of cotton or cellulosic textiles with a concentrated solution of alkali with or without tension for a given period of time. Now, let's know what is the classification of mercerization process. The mercerization process can be classified into two categories. The first one is tension mercerization, and the second one is Lect mercerization. What happens in tension mercerization is the luster is improved and the strength and dye uptake of the cotton textile is improved. And in the slack mercerization process, there is no significant improvement in luster, but there is increase in elongation and recovery properties of cellulosic textiles. Again, the tension mercerization was developed by Louis, and the slack mercerization was developed by Mercer. Now, after covering this part, let's discuss about the objects of mercerization. First object is to improve the luster. Of cellulosic textiles. Second object is increase in tensile strength. Third is increase in dimensional stability. The fourth object is increase in dye uptake. And the fifth and final object is to improve the elasticity of the cellulosic textiles. So the main objects are increase in luster, increase in tensile strength, increase in dimensional stability, increase in dye uptake, and increase in elasticity. Now, after covering the objects part of mercerization, let's move on to the mechanism. Mechanism of mercerization. Actually, what happens during mercerization in the chemical and physical structure of cellulosic textiles, we can show in the process of mechanism of mercerization. The first change that takes place is swelling of fiber. When the cotton textile is treated with concentrated solution of sodium hydroxide or any other alkali, then first changes that takes place is swelling of the fiber. The second changes is the cross section becomes rounder. The convolutions is removed, that is deconvolution. Deconvolution. And also there is increase in luster. Again, the fiber structure is opened up. Next, the number of hydroxyl groups are increased. The effect of mercerization is best observed at a concentration of 56° total and at a temperature of 15 to 18° centigrade. Now, there is also some changes that takes place is improved dye uptake, improved reactivity, and improved elasticity. Beside this, one of the major changes that takes place is there is increase in orientation in the chain molecule of the fiber structure. What are the major changes that actually takes place is, first is swelling of the fiber, second is the cross section becomes rounder, deconvolution takes place, and there is increase in luster. The fiber structure is opened up, the number of hydroxyl groups are increased. The effect is best observed at a concentration of 56 degree total and at a temperature of 15 to 18 degree centigrade. Besides this, improved dye uptake, improved reactivity and improved elasticity is also observed. One of the major changes that takes place is orientation in the chain molecule of the fiber structure. Now after covering the mechanism part, we will next move to what are the major changes that takes place during mercerization. So, changes that takes place during mercerization. Changes that takes place during mercerization are in 3 levels. First is in the fiber level, second is in the molecular level, and third one the chemical changes. So let's discuss in detail of these 3 changes. First is changes in the fiber level. In the fiber level, first changes that takes place is swelling of the fiber. The next changes is the cross section of the fiber changes from kidney shape to round shape. The next is longitudinal shrinkage. So main changes in the fiber levels are swelling of the fiber, then cross section changes from kidney shape, as the cross section of the cellulosic textile or cotton fiber is kidney shape, it changes from kidney shape to round shape, and due to lateral swelling the longitudinal shrinkage also takes place. So next, changes in the molecular level. In the molecular level, the first change that takes place is there is increased orientation of the fiber in the amorphous region. Along the chain length of fiber. The second change that takes place in the molecular level is increased in orientation of crystallinity along the fiber chain length. So, the orientation in the amorphous region and also in the crystalline region. Both the region the orientation is takes place. Now let's see what are the chemical changes that actually takes place. The first change that takes place is there is increased in number of hydroxyl groups. Second change is increased in the absorption of alkali. Alkali means sodium hydroxide, potassium hydroxide or any other alkali. And the third change that takes place in the chemical level is increase in absorption of iodine. So, main changes that takes place during chemical level is increase in number of hydroxyl groups, increase in the absorption of alkali, and increase in the absorption of iodine. Now, next move to the next topic. What are the changes that takes place in the properties of cellulose during mercerization? So first changes that takes place in properties of cellulose is swelling and shrinkage. Now, why swelling and shrinkage actually takes place during mercerization is the reason behind the swelling is the absorption of alkali hydrates. And the reason for shrinkage is as there is lateral swelling of the fiber molecule. Due to this or due to the consequence of this, there is longitudinal shrinkage also observed. So these are the regions where swelling and shrinkage during mercerization takes place. Now the next change that takes place is structural modification. This is the most important point. Here, the chemical structure of cellulose is changed from cellulose 1 to cellulose 2. Now let's know what cellulose 1 is. is the structure of chemical structure of cellulose 1, or it can be also called as native cellulose. This is the alkali, that is sodium hydroxide. When this cellulose 1 reacts with sodium hydroxide, it gets converted into this is called as sodium cellulose. Again, when it undergoes hydrolysis, it again gets converted into this is called as cellulose second. So first cellulose first or native cellulose reacts with alkali, that is sodium hydroxide. It gets converted into sodium cellulose, and again hydration of sodium cellulose causes or results in the structure of cellulose second, and sodium hydroxide is the byproduct of this. Now chemical structure looks same in both cellulose 1 and cellulose 2. Now what are the main changes, major changes that takes place? Each changes in the dimension, it is change in dimension or crystal unit structure of cellulose. Now let's draw the crystal unit structure of cellulose first. The dimension is 8.2 angstrom, this is 6.0 angstrom, this is 5.4 angstrom, and this is 7.8 angstrom. This is the crystal unit structure of cellulose first. And crystal unit structure, here you can see the changes that actually takes place from cellulose 1 to cellulose second. Now you can clearly see the changes of dimensions. That in previous cellulose 1 it was 8.2 angstrom, here it is 8.1 angstrom. It is 7.4 angstrom. Now this is 4.4 angstrom, and this is 9.1 angstrom. Now this is the major chemical change that takes place.